Section 2.3, we will find perimeter, circumference, and area. So just to name a couple of vocabulary words, a polygon is a closed plane figure with at least 3 straight sides. So a triangle is a polygon, a square is a polygon, a rectangle is a polygon. The perimeter of a polygon is the sum of the lengths of the sides of the polygon. So we can find the perimeter by adding up all the sides. There are some special formulas for perimeter based on their shape. So for a triangle, you can add all the sides. For a square, you can still add all the sides, or if you wanted to, you could just do 4 times one of the side lengths. And then for the rectangle, add all the sides, or you can do 2 times the length plus 2 times the width. The circumference is the same as a perimeter, but just for a circle. So this would be the distance around the circle. We just call it something different. And then the area is the number of square units that are inside of that shape. So how much would it be to cover the inside? Sometimes you have to use the distance formula to find the perimeter and area of a polygon. And that's what's going to be revisited down below. Some other important words: an equilateral polygon are all sides congruent, an equiangular polygon has all angles congruent, and a regular polygon is where you have both of those. So it would be equilateral and equiangular. Take a look at that first example. It's asking us to find the perimeter or circumference and then also the area. So the first thing we have to do is we have to find the length of the sides since I have a rectangle. So I use the distance formula. So I did -4 minus 1 and 2 minus 7 and found the square root of 50, which is 7.1. So the length of this side is 7.1. Then I did the same thing for this side. So I grouped my x's together, grouped my y's together, found it was square root of 32, and found that guy was 5.7. Remember, with a rectangle, your opposite sides are going to be equal. So this would also be 5.7, and this side would be 7.1. So all I would have to do is add up all those sides, and I would get 25.6. Then for the area, I look up here for my rectangle, and I find that formula. So the area formula for a rectangle is length times width. So I just did 7.1 times 5.7, and I got my area, 40.5. Now, usually when we are putting on labels, if there's not like inches, centimeters, you just put a U there for units. So perimeter, I'd put units, and then for area, I'd put units squared. All right, let's take a look at another example. On the next page, you're going to look at the circle to the right where it has letter B on it. Okay. So if I'm doing a circle, I first need to do circumference. So I need to do my formula, which is C equals 2 pi r. I need r, which is the radius. So as I look at my picture, I'm going to have to do the distance formula to know how long my radius is. So that's what I'm doing here. So I grouped my x's together, so 4 and 6, grouped my y's, and then I typed it in, and I got 5.4 for my radius. So then I just typed in those numbers. So on your calculator, you should be able to find your pi button on its own right here above the caret key. So I did 2 times pi times my radius, which is 5.4, and then I set it equal. So I got 33.9 units. The area formula on the previous page for a circle says pi times radius squared. So I already found my radius, so all I have to do is plug it in. So pi times 5.4 squared. So pi times 5.4 squared, hit enter, and I get 91.6 units squared. You're going to pause the video and try the check question, which is the circle to the left over here. So over here, you should be doing the exact same process we just did on letter B. You need to find the circumference, so use the correct formula. I need the radius, so I need to know the distance between these 2 points. So I grouped my x's together, so -3 and 0, my y's together, and I got 7.6. Now I can plug them in to find my circumference. So 2 times pi times 7.6 gives me the circumference. The area formula is pi times radius squared. So I'm plugging in my radius that I found. So pi times 7.6 squared, and I get my area. Okay, In this section, it talks about modeling with two-dimensional figures. So a geometric model is a geometric figure that represents a real-world object. So down here, you'll notice that you're going to have a plate of food and realizing what actual shape is that plate. So it says use an appropriate two-dimensional model and the dimensions provided in the image to calculate the perimeter area. So just like I was saying, this is an example of a square, right? A plate of beans. So if I just have a square and I want to find the perimeter, I just add up the sides to find the perimeter. And that's what I was doing here. You can also use the formula from the previous page where it says just do 4 times this since it's a square. So my perimeter would be 50 inches. Then to find the area, I'm doing length times width, or I'm doing this squared. Either one would give you the correct answer. So 156.25 inches squared. Pause the video and try the check question to the right. So in this question, you've got framed art. So it looks like we have a rectangle. So I'm using the formulas for a rectangle. So I did 2 times my width plus 2 times my length, and I got 203.2 centimeters. Then to find the area, I'm doing length times width. So I'm doing 40.6 times 61, and I get 2,476.6 centimeters squared. Now, the whole point of why they practice you doing all of that is so that you can apply it to a real-world situation. So down here at the bottom, you see a picture of a cafe, okay? And you've got tables, you've got a counter, and then you've got a place over here where you come get your drinks. Part A says a new fire code states that there must be at least 15 square feet of free space for every customer in the cafe that Isaiah owns. How many people can be in the cafe? So the first thing we want to do is figure out how much is in the entire room. Okay, so since this is a rectangle, I just did 15 times 15 and I got 225. Now my next step that I want to do is start taking away these spaces where people won't be able to stand, right? So I'm not going to be able to stand in the counter region, the tables, or the drink station. So we're going to need to find the area of these and take them out of that whole area. So the cafe counter, I counted my length and my width. So that's how I got 3 and 11. And so I found the area by just timesing 3 times 11. Then for the drink station, I again counted how long these were based off the boxes in the picture. So the bottom I found was 6 and the height I found was 5. So area of a triangle is a half times base times height. So I did half times 6 times 5 and got 15. Now for the tables required a little bit more work. So you can just use one table because they end up being the same when I looked at their coordinates. So I'm going to need to know the length and the width. So I have to use my distance formula to find it. So I did the length over here would be this distance formula. So that's where all of these numbers are coming from. So to find that, I found my length was 4.5. And then over here, I did the same thing and I found my width to be 2.2. So the area of one table was 9.9. So once I had all of that, what you can do is take our total that we had and subtract away all of those things. So I'm over here taking my total, subtracting away the counter, the drink space, and then I had 2 tables, so I took away 9.9 2 times. And so this would be how much free space I would have in the room. The next question is how many people can actually be in there? So once you have that space, you can divide it by 15 to figure out how many customers will actually be in there. So I just took that number divided by 15 and I got 10.5. Now think about it for a second. That's people, right? Typically for rounding, we would round up, but since this is going off of how much space is needed for each person, you're going to round down. So I can only have 10 people to provide in that space because I don't have enough space to go up to 11. Okay, and then in part B, it says Isaiah wants to hang garland around the tables and the drink station. How much garland does he need? So here are my tables. So if I'm trying to figure out how much that would be around it, that's a question of perimeter. So I'm just finding the perimeter of the 2 tables and the perimeter along the drink station. So I did 13.4 for my, because I already found my length and my width, so I just used those same numbers. So I did 2 times my length, 2 times my width for the perimeter, and I got the table to be 13.4 all the way around. For the drink station, I already knew this was 6 and this was 5. I had to do the distance formula to find this part right here. So I did the distance formula using these coordinates and found that length to be 7.8. So when I added that up, that gave me my perimeter. So then I could take my 2 tables, 13.4 times 2, my 1 drink station, and add all of those up. So I need 45.6 units or feet of garland. All right, folks, so this section is about circumference, perimeter, and area. It is applicable to the real world because you can use it finding area and perimeter of certain things, and that's what that later part of the lesson was about.